Hey guys, welcome to the final week and the final advanced concept presentation. So today we're going to be, I'm going to be demonstrating rapid freezing or ice bending as the video says. And this week's experiment is very straightforward as it only involves water bottles, some filled with purified water, and a freezer to freeze them. So I have here some distilled water. I looked, I did some research and uh, I know the experiment mentioned purified, but as long as they're void of any other contaminants and has been filtered, that's what I'm gonna move forward with this experiment with distilled. So what I did, I had to improvise. I took regular Poland spring water and I poured it out, and I filled it up with some distilled water, and I put them in the freezer and waited 2.5 hours. So after the time was done, you see we had the water here, and according to the instruction video, if you just give it some quick shock or some quick stimuli, it went from being observable, it went from being sort of liquid to just straight ice. Now, with the second part, we are supposed to pour water over ice cubes, and as the water makes contact with the ice cubes, the interaction between the two transforms ice as it is poured, creating a cool ice bending effect. And after that, the third experiment is placing an ice cube in the distilled water and observing the crystallization and rapid phase change of water into ice. So the second you drop the ice cube in the water just instantly crystallizes, it freezes up. Once again, another variation of that quick rapid phase change. Now, while I enjoyed success in the first procedure, as you can see, for some reason, I wasn't able to reproduce or induce the same effect in the other two. Keep in mind, this is an experiment, and while I recognized and understood and executed the experimental design, failures do happen. And with respect to the reproducing the experiment, there were many factors that could have changed or affected my personal experiment. For one, I did use a specific kind of distilled water instead of purified water. And even though they are practically the same concept-wise, um, the the process they undergo, distilled and purified, um, they it might have been different, and this could have made a slight difference in the experiment. Another variable was that I had to empty my Poland spring water out as an improvisation, and during this whole improv, maybe some of the Poland spring water was still there. I like these slight nuances all play in a role, and also the time that I took to place them in my freezer matters, and so does the temperature of my freezer. So, to ensure accuracy, more trials are needed, and the variables that I just mentioned could be better controlled for more accurate results. But even if I experienced failures, I still understood the design, and I'm gonna break down the concepts of behind this experiment right now. So what are we doing in this experiment in all three variations? Well, we are obviously illustrating phase changes that can occur quickly by provoking them by either through inducing a stimuli or shocking them suddenly. We see that the water transforms from water to ice very quick. And to understand this, we need to be familiar with the phase change. So in this particular experiment, the phases that are involved are solid and liquid. And to understand the transition between the two, when a liquid is cooled, the average energy of the molecules decrease, and at some point, the amount of heat removed is great enough that the attractive forces between the molecules, they draw the molecules close together, and it's this transition and change of molecules being closer together and its attraction, that's how a liquid essentially freezes to a solid. What may cause a phase change to occur once again? A phase change can occur when enough energy is applied to the system, or it can occur when the pressure on the system is changed. So, a factor here obviously was when we induce that pressure. That pressure provoking it can induce a phase change with respect to the attraction of the molecules and the energy applied. Heat is another factor, as we saw with the interaction between the water and the ice cube. As we put the ice cube in the water, it crystallized almost immediately, and that's because in the earlier weeks, we talked about endothermic and exothermic reactions, the transfer of heat and energy between some two objects, and where as water keeps in contact with ice, and which is cooler, this transfer of heat is still applicable here, and that's why we're able to see such quick phase changes between water and ice. But this experiment was, once again, it was very straightforward, and through rapidly freezing, we were able to observe and reproduce some results of a simulation of ice bending. And yeah, in conclusion and summation, with everything kept in mind, the concepts, the science behind the instant ice is that when the ice freezes, the water forms small crystals that they gradually spread. And if you catch the cold water before the crystals have time to form, you can still pour out the water, as we saw, or in the video, it would freeze as you pour. And this is essentially because pouring over an ice cube, it would trigger the crystals to form faster than they normally would. And that's the common theme of this experiment, just stimuli, whether it be stimuli through provoking change, whether it be hitting the water bottle or putting it in interaction with ice cubes. And through that, the instant freeze experiment, those are the concepts that they illustrate. Yeah, in other words, the water in the bottle, it turns into ice instantly because it's super cooled already, and a super cooled liquid is one when the temperature is already below the normal freezing point in the liquid, but the liquid has not solidified. So provoking that change affects that, and that is what really causes this effect. Thanks for watching, guys.